All right. This is for FOM 11, Chapter 5, Section 6, the last section of Chapter 5, and it deals with this thing called confidence intervals. It says here, when we want to collect information about a population, it's not always feasible. I mean, it doesn't always make sense to survey an entire population. Instead, we take a sample, take the mean and standard deviation, and use them to make predictions. How confident can we be that the data from our sample is true of the entire population? Meaning, how sure are we that our sample actually is a smaller version of the entire population? So before we begin, we need a couple of definitions. So the first thing is this thing called the margin of error. The possible difference between the estimate of the value you've determined from your sample and the true value of the population. So how far off are our measurements from the sample compared to the true measurement of the entire population? So it's typically represented as a plus or minus of a particular percentage. So for example, plus or minus 3.5%. Okay. Now, confidence interval. A confidence interval is the interval in which the true value is estimated to lie. So for example, 42%, let's say 42% of the population like the color blue. But we have a margin of error of plus or minus 3.5%. So the confidence interval, let's say, is instead of 42% liking the color blue, we could be as low as 38.5% liking blue to as high as 45.5% liking the color blue. Now, the next definition is what's called confidence level. The likelihood that the true value lies within the confidence interval. The survey usually uses a confidence level of 19 out of 20 or 95%, sometimes 9 out of 10 or 90%, or 99 out of 100, which means 99%. All that means is when you have a confidence level, it just means that 19 out of 20 surveys, for this example, 19 out of 20 surveys, 42% would be roughly, the people that like the color blue would be somewhere between 38.5 and 45.5%. If we did the survey 20 times, 19 times we did the survey, the true number of people, or the true percentage of people that like the color blue would be somewhere between these ranges of 38.5 and 45.5. Now, the odd time, it might be higher. Okay? All right, so let's take a look at our first example. It says here, nationally, the majority of Canadians, 55% say they are excited that Will and Kate are touring Canada. So the Ipsos Reid poll, it's just a company that does polling, gathered opinions from 1,016 Canadian adults. Between June 20th and 27th, the results considered accurate within 3.1 percentage points, 19 out of 20 times. So what is the margin? What is the margin? What is the margin of error? Okay, so what is the margin of error? Well, the margin of error is this guy here, plus or minus 3.1%. So we know that 55% of the people are excited, but we're not exactly sure if it's exactly 55%. It could be 55% plus 3.1% or 55 minus 3.1%. Okay, so the margin of error is the 3.1%. What is the confidence interval? Well, now we're actually going to do the calculation. So 55 minus 3.1 could be as low as 51.9% of the people are interested in seeing Will and Kate, or as high as 55% plus 3.1, that's going to be 58.1%. So it's going to be between these two values. So as low as 51.9%, as high as 58.1%. What is the confidence level? Well, the confidence level is if we did 20 polls, 19 of those polls would be roughly around this area. Okay, so what is the confidence level? The confidence level is 19 out of 20, or also known as 95%. Now, what does this all mean? So it means that we are sure 95% of the time that somewhere between 51.9% all the way to as high as 58.1% of the people are excited to see Will and Kate. Okay, so the confidence interval is 51.9 to 58.1, but the confidence level is 95%. Now, question E says the population of Canada is approximately 34 million. It's not, it's actually 38 million. It can be said with 95% confidence. What is the range of people that are excited to see Will and Kate that are coming to Canada? Okay, well, 95% confident. Well, if we use the number 34, we know that it's going to be 0.519. That's 51.9% are excited. That's the low end. And we're going to multiply against 34 million. Now, on the high end, it's going to be 0.589%. Oh, sorry, not percent. That's the decimal equivalent. So it's 0.589 times 34 million. So on the low end, we expect something like 17,646,000 people are excited to see. And on the high end, it's roughly 19,754,000. So on the low end, it's around 17 million. On the high end, a little higher than 19.5 million. Okay? All right, moving on. It says here, consider the following polls from November 2010 on voter preference. All polls are accurate 19 out of 20 times, so they're 95% confident. Now, so it says polling, these are the different polling companies. So when they polled 29% are conservative, 29% are liberal, 19% are NDP, 9% are Bloc Québécois, the Green Party, and there's a whole bunch of people that are undecided. And their margin of error is plus or minus 2.3%. Nanos does the exact same type of poll. Instead, they get 37% conservative, 32 liberal, 15 NDP, and so on. And their margin of error is a little bit bigger. Ipsos. Well, they did the exact same poll, and their margin of error is slightly smaller. So it says when the sample size is larger, all right, when the sample size is larger, let's take a look. Sample size is 1815, so 1,815. Sample size is small. The sample size here is in the middle, it's 1,000. So when the sample size is larger, what happens to the margin of error? Well, you can sort of imagine as the sample size gets larger and larger and larger, they're getting closer and closer to basically polling the whole population. Now, mind you, the population in this particular example assumes 34 million. But if you had the time and energy and the manpower, and if you polled everybody, and you polled 34 million, what would happen to the margin of error? Well, the margin of error would decrease so small that it would be the exact answer. Now, 1815 is, of course, a small number compared to 34 million, but it's definitely bigger than these two. So when the sample size is larger, what happens to the margin of error? Well, the margin of error decreases. Because as you get closer and closer to sampling the whole population, then you're going to get closer and closer to the true answer. When the sample size is large or larger, what happens to the confidence interval? Well, if you take a look, plus or minus 2.3%. Well, that's the range. Here, plus or minus 3.4%. So the range is bigger. The range here in this one is middle size. So when the sample size is large, what happens to the confidence interval? Well, the confidence interval or the range of values decreases because you're getting more and more accurate, right? You're getting closer and closer to the actual value in your population. All right, part C. It says here, a baseball manufacturer intends to create baseballs that have an average, right? An average mass of 145 grams. Each day they take a random sample of baseballs and the mean is somewhere between 144.7 and 145.3 grams. If they do that, then everything's fine. Otherwise, the production stops and equipment is recalibrated. The following chart is used to determine what sample size is needed for a particular confidence level. Now, if they want to be confident 99 out of 100 times, they're going to need to sample 110 baseballs. If they only want to be accurate 95% of the time, which is 19 out of 20 samples, they're going to need to sample 65 baseballs. And if they're only interested in 90%, which is 9 out of 10 times, they need to sample only 45. First of all, it says here, can you determine the confidence interval and margin of error? Well, we know that the mean is 145. So we know the mean is 145. If the high end is 145.3, 145.3 minus 145, we know that on the high end, we're willing to accept 0.3 grams difference. Now, if we know again that on the low end, it's 144.7 grams, and we know the mean is 145, well, we're willing to be short 0.3 grams. So what is the margin of error? Well, the margin of error is plus or minus 0.3 grams. Part B says, what does the information in the table mean? Well, if you want to be absolutely sure that your machine is producing baseballs that are 145 grams, you want to be 99 out of 100 times that you do a sample run, you're going to need to sample 110 baseballs. If you're willing to, stop production every once in a while, and you want to be confident only 95% of the time, then you don't need to sample so many baseballs. You only need 65. And if you're confident, or if you only want to be confident 9 out of 10 times, that means, you're going to have to stop production a little bit more frequently, while you only need to sample 45 balls. So, to be sure, 99% of the time, you need to sample 110 baseballs. If you only want to be confident 95% of the time, well, you don't have to sample so many. You only sample 65. And if you only want to be confident 90%, well, then you only sample 45. Again, it says here, what happens to the confidence level as the sample size increase? Well, sample size increases if sample size increases, and if you continue to increase it enough, there's a possibility that your sample size could be the whole population itself. That means you're going to get more and more accurate. Which means that your margin of error, right? As long as your sample size gets larger and larger, your margin of error actually gets smaller and smaller. All right, question number 4. It says a poll was conducted. If an election were held today, who would you vote for? Now, you might not recognize these two guys, but they are both actors. In fact, Ron Howard here is actually a very, very famous director now. And it says here the results are accurate within 3.5%, 19 out of 20. So what is the confidence interval for Clint? Well, Clint is 52.9%. They would vote 52.9% plus or minus 3.5%. So his voting percentage would roughly be as low as 49.4%. He would get 49.4%, all the way up to as high as 56.4%. Ron, on the other hand, he has 47.1% vote, but it could be plus or minus, again, the same confidence interval, 3.5%. So the lowest he would possibly get is around 43.6%, and the highest he would get is 50.6%. Is it possible for either man to win the election? Well, the answer is yeah. Here, there's a possibility, well, there's a high possibility that he's going to get more than 50%. Ron Howard, on the other hand, there's a slight possibility, right? Because he's got higher than 50%. So yeah, there's a chance that both of them both of them win. Now, it says here, could Ron possibly get 50.7% of the vote? Well, remember that this poll is only accurate 19 out of 20 times. So is there a possibility that he can get 50.7% of the... Yes. Yes. There's a very, very slight chance. It's at 1 out of 20, actually. 1 out of 20 times could he actually have a higher vote percentage. So yes, 1 out of 20. And the reason being is we are only 95% confident. Okay. All right, so that concludes chapter 5.